Find the moment of inertia of rigid diatomic molecule about different axes of symmetry to the center of mass. This question appears in IAS 2019. It is a 7.5 marks question. Now let's try to solve this question. By definition, moment of inertia for discrete system is given by I is equal to summation of I varies from 1 to n mi ri square. With this axis of symmetry, axis of rotation, and these are the location of the different particles m1, m2 and mi. And Ri is the distance of mass mi from the axis of rotation. Now, for two particle system, assuming mass m1 and m2 are located on the x-axis, and distance between them is r, and the y-axis passing through the center of mass. Now assume that distance between the center of mass and mass m1 is r1, and distance between center of mass and mass m2 is r2. Then location of center of mass from m1 is r1 is equal to m2r upon m1 plus m2. Because by definition, center of mass is equal to summation of mi/ri divided by total mass, that is summation of mi. Now by using the same formula, location of center of mass for m2 is r2 is equal to m1r divided by m1 plus m2. Now, because of this symmetry, moment of inertia about y-axis and z-axis is same. Moment of inertia about y-axis is same as about z-axis because of symmetry. So I y is equal to iz is equal to m1 r1 square plus m2 r2 square. Now by putting the value of r1 and r2, we can say m1 m2r upon m1 plus m2 square plus m2 m1r divided by m1 plus m2 square. Now taking r square upon m1 plus m2 square common, we left with m1 m2 square plus m2 m1 square. Now again taking m1 m2 common, we left with m1 m2 into m1 plus m2 into r square divided by m1 plus m2 square. Now we cancel out m1 plus m2, then we left with m1 m2 upon m1 plus m2 into r square. Which can be written as nu r square, where nu is known as reduced mass. Given by nu is equal to m1 m2 upon m1 plus m2. So this is the moment of inertia about y-axis and z-axis passing through the center of mass of two particles. Now moment of inertia about x-axis is 0. So I can say Ix is equal to 0. Because both particles lies on x-axis. Because both particles lies on x-axis. So their perpendicular distance from x-axis is 0. So the perpendicular distance from x-axis is 0. In this whole calculation, we assume that atoms are point object. Thank you.